Write down features of quantum mechanical model. Features of quantum mechanical model. Already you know it, we are just noting it down. Features of quantum mechanical model. Number one, energy of an electron is quantized. Energy of an electron is quantized. In bracket you write, means it can have certain specific value only. It means it can have certain specific values only. It can have certain specific values only. Number two. Quantized electronic energy levels. Quantized electronic energy levels are the allowed, ALLOWED, allowed solutions of Schrodinger wave equation. Schrodinger wave equation. Schrodinger wave equation. Number three. The exact position and the exact velocity of an electron in an atom cannot be determined simultaneously and accurately. The same thing what we have learned. Simultaneously and accurately.
क्या बोल दिया, अब तो मेरे को पता ही नहीं पड़ेगा.
Manish Kumar, put off your audio. Number 4, an electron in an atomic orbital can be described by a wave function xi. Number 5. Probability of finding electron in an atom is proportional to modulus psi square. modulus psi square. We know that modulus psi means that is a positive value. Then why to put modulus psi square? Square itself gives a positive value. This is to show that psi has got negative sign also. It is a wave function like a sine omega t on the axis, negative axis also. There it has got values. Psi has got negative values also. To show that we are putting like this. Otherwise, there is no need of putting a modulus psi square. If square comes already, it will be changing into positive. Still, we are putting that psi means psi can have negative values also. Number 6, an orbital can accommodate maximum of 2 electrons of opposite spin That's all. These are the features of quantum mechanical model. Next, we are going to see boundary surface diagrams. Boundary surface diagrams. Boundary surface diagram is same as the shapes only. Shape of S orbital, that is spherically symmetrical. Shape of P, that is dumbbell shape. Shape of D orbital, that is double dumbbell shape. So orbital wave function psi for an electron in an atom has no physical meaning. Psi has no physical meaning, but its square, that is psi square, modulus psi square, gives the probability density of an electron at any point. So at one point, if you get psi square value, there is the presence of electron. From the value of psi square of different point within an atom, it is possible to predict the region around the nucleus where the probability of finding electron is maximum. That is the orbital. So what are the boundary surface diagram? Actually, we are putting dot, 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 dot. And all the dots together, you visualize what is the shape. That is the boundary surface diagram. So you are finding out modulus psi square, and wherever you get that modulus psi square, that means you put a dot over there. Like that, we are putting the dots. We are putting x-axis, y-axis, z-axis, and the probability density. You are putting the dot wherever you are getting psi square value. So all these dots together you visualize, you will be getting the boundary surface diagram. We call that as boundary surface diagram, spherically symmetrical S orbital. If it is P orbital, so this is S orbital. Boundary surface diagram for S orbital. Now for boundary surface diagram for P orbital, to show the boundary surface diagram, you have to put only the dots. Put the dots and show the shape, that's all. That is the boundary surface diagram. If it is for Px, so for Px, I'll be showing like this. So this is Px. One lobe is positive and the other lobe is negative. Boundary surface diagram. Do not draw like this because this is a cloud, electron density, that is a cloud. So it does not have visible clear boundaries. It is in the diffused state, spread, diffused state. No clear boundary for this thing, only in the diffuse state. Next, boundary surface diagram for d orbital. Shape is same thing, only here to put in terms of dots. So, for example, we'll be drawing dxy. So, one x-axis, one y-axis, one y-axis. So, here one lobe positive, here positive, negative, negative. So this is the boundary surface diagram for d orbital. dxy like that, dy z, dx z, these are the boundary surface diagrams. Next is you are seeing this orbital at a particular distance from the nucleus. So if you draw a graph between this radius from the center, from the nucleus, if you are moving in the radial way, in the radial direction, at some positions you see higher density, that is chi square, modulus chi square. So wherever you are getting maxima in the graph, there is the presence of one orbital. So if you are going to draw a graph between the radius, this r, that is radius and modulus chi square, means you are going to find out the probability density. We are going to find out the probability density. This is the nucleus. From the nucleus you are moving along the radius. At what all positions you are getting this very high value for this chi square. So suppose you started moving in this way, you got a maxima over here, this point. At this point, you have got that maxima. So the graph after that, in the case of oneness orbital, you are getting only one maxima. So this you can write it as for this for oneness. This is for oneness. So you write down here for oneness. For oneness, you get only one maxima. That is at a particular distance. So that is for oneness. From the nucleus, at a particular distance, you are getting this maximum. So here, boundary surface diagram for that oneness is what we have shown like this. Means distance, at this distance you get that oneness. Now again we are moving along the radius only, along the radius we are moving. So you are, after some time you are getting, suppose you are getting one more maxima. That means that is 2s orbital. So for 2s orbital, oneness is there. Again you are moving along the radius only. So for 2s you are getting, you have to draw it again. So here it comes to the zero. Zero means probability density, no probability density, zero probability density. Again it is rising and you are getting one more maxima here. So like this. So for 2s, you are getting two maxima, that is 1s and for 2s. So two maxima. In this way, you will be able to get like this. In this way, you will be able to get at different distances, you will be getting the probability density. Now, in the case of 2s, there is already 1s inside, So the density for 2s, that is like this. This is for 1s, and after that it comes to a minimum. There is no probability density. And again you are moving, and the next probability density you are getting. So that is for 2s. So between 1s and 2s, there is no probability density. At this point, there is no probability density. That means between 1s and 2s, we have no probability density area. That area is called a nodal surface. That is called a nodal surface. So this position is a nodal surface. So write down nodal surface, or simply nodes, N-O-D-E-S, nodal surface. So this area in between that, where the probability of finding electron is 0, that is nodal surface. So write down nodal surface. Nodal surface or nodes. Nodal surface or nodes. You have to learn one sentence for this nodal surface. Define a nodal surface. Write down the intermediate region, which in between this, the intermediate region, where modulus psi square reaches 0. This modulus psi square reaches 0. The intermediate region where modulus psi square reaches 0 is called nodal surface or nodes. Nodal surfaces. There may be many nodal surface or nodes. Intermediate region where psi square reaches 0 is called nodal surface or nodes. Now there are two types of nodes. There are two types of nodal surfaces: spherical nodes and planar nodes. Spherical nodes nodal surface. Or nodes. Spherical nodes means go length between 1s and 2s, between 2s and 3s, between 3s and 4s, like that. Spherical, spherical nodes and planar nodes in plane, in plane. For example, like this, one plane. In this plane, you will not see any electron. In this plane, you will not see any electrons. Suppose px orbital. Px orbital, one lobe above, one lobe below. One lobe above, one lobe below. So we beach ka, that this plane, between the lobes, this plane, on this plane, you will not see any electron. Probability density is 0. Modulus psi square is 0 along this plane. So such nodes are called planar nodes. Planar nodes or angular nodes. Angular nodes in the sense you can make this plane into a cone. I'll take one sheet and I make a cone like an ice cream cone. This cone, okay, consider an ice cream cone. So on this also, on this cone, bigger cone, bigger cone, see this cone, bigger cone, bigger cone, bigger cone, bigger cone, bigger cone, and it becomes a plane. So planar nodes is also called angular nodes. This angular nodes, inside is the lobe, inside is the lobe, okay. So this is angular node, angular node, angular node, angular node, this is angular node, same thing, but now it looks like a plane, so we call it as planar node. So spherical nodes and planar nodes, planar nodes are also called angular nodes. So nodal surfaces means the intermediate region between two orbitals, that beach region where the probability of finding electron is 0, that is called nodal surface. There are two types of nodal surfaces, that is spherical nodes and planar nodes. Spherical nodes are also called radial node. Radial node. It is given by n minus L minus 1 and this is given by L. For a particular orbital, how many spherical nodes are there, how many planar nodes are there, that is given by, see, spherical nodes are given by n minus L minus 1 and angular nodes or planar nodes are given by L. So what is the total number of nodes? Total number of nodal surfaces, yeah, nodes, total number of nodes is equal to n minus L minus 1 plus that L. So it is equal to n minus 1. Total number of nodes is equal to n minus 1. Total number of nodes is equal to n minus 1. Okay. For 2s, you see, this is 1s and this is 2s. It's the intermediate region between the orbitals. So for 2s, one spherical node. For 2s, one spherical node. What is 2s? N is equal to 2, L is equal to S. So 0 minus 1. So 2 minus 1, one spherical node. That this is that one spherical node. Okay, for 2s. For 3s, for 3s, for 3s, that is 3 minus S 0, S ka L value 0 minus 1, that is 2. That is 1 is this and second is this. So 2 spherical nodes. For 4s, 3 spherical nodes. For 5s, 4 spherical nodes. For 2s, 1 spherical node. For 3s, 2 spherical nodes. Now planar nodes. P orbital, planar nodes. P orbital is like this. So between, I can put that plane of paper, that sheet of paper, I can put like this between. So on that paper, no probability density or probability of finding electron is 0. That means that plane, that paper what I have shown, I can put that paper along this line, and there that plane is a planar node. So for P, P ka L value is 1. That means one planar node. One planar node. So that is that plane. Planar node or angular node. I can put that paper. I can put that paper in between this thing. That means on this paper, probability density is 0. So how many nodal planes are there? How many nodal planes are there? That is 1. That is its L value. Its L value means 1. L is equal to 1. P ka L value is 1. So P orbital has got one planar node. What is that plane? You can show like this. This plane. On this plane, no probability density. On this plane, no probability density. So this is the planar node. What is the total number of nodes? That is n minus 1. In the case of d orbital, there will be two planar nodes. For easiness, we draw this using solid lines. Actually, it is in the diffused way. So, for example, dxy. This is a d orbital. D orbital. See, one plane is like this, and the other plane is like this. So, two planes are there. I can put this paper like this. One paper like this. You will not see any electron on this paper. Similarly, paper like this, vertical. So on this also you will not see any electron density. That means two nodal planes are there. So two planar nodes are there, or two angular nodes are there in the case of dxy, dyz, dx. But in the case of dx square, in the case of dz square, there is no planar nodes due to its shape. dz square. This is z axis. This is dz square. In dz square, there is no angular nodes. So dz square has no planar nodes, no angular nodes. Total number of nodes is equal to spherical nodes plus planar nodes. Thank you.
Thank you, ma'am.
Thank you, ma'am. Bye bye.